Hi, my name is Jingjie. I currently work at Google Canada, still kind of doing research. So this work was done primarily with Daniel Vogel from University of Waterloo with the help of Jeff Avery and Blaine Lewis. And I continue and finished after I joined Google. Today, I'm introducing a new type of keyboard shortcuts we call guided finger shortcuts. And there are two variations to that, FingerArc and FingerChord. So now let's first step back a little bit to talk about usability in general. For desktop computing, we often refer to two things when we talk about usability. Ease of use brought by the GUI and efficiency achieved with the keyboard shortcuts. The issue here is that we know most users don't fully leverage keyboard shortcuts. Just out of curiosity, let's just do a quick survey here. Take any of your favorite text editor, Google Docs, Sublime, Word. Who uses menus and icons? Please raise your hands. Menus and icons? Who uses keyboard shortcuts? Who can memorize on top of your head 5 keyboard shortcuts? What about 10? 20? 30. Now here's the problem. Now we just proved that we are dealing with a legit research question. So, how can we help users learn keyboard shortcuts? What's really the issue here? To systematically understand this, we conducted a semi-structured interview study with 12 expert users. They all came from computer science background, make regular use of different operating systems and complex applications like IDEs. We recruited experts because they can be more reflective than novices on the issues and challenges in learning and using keyboard shortcuts. During the interview, we probed different aspects of keyboard shortcuts. We asked questions like, when do you use keyboard shortcuts? When do you learn it? What motivates you to learn it? What shortcuts are easy to remember? What shortcuts you tend to forget? These questions were really to help us uncover the basic usage, learning, physical articulation, and feedback aspects of keyboard shortcuts. Then we used semantic analysis to identify themes that are recurrent within our participants and our data. Now here's the result. What really affects shortcut learning and usage? We identified 9 different factors. The dominant factor, of course, we found is the frequency of the use of commands. In general, the more you activate a certain command, the more likely you will try to learn its keyboard shortcut. But we found it's a little bit more complicated than that. It's also related to the perceived cost between GUI and the shortcut. So it's a comparison. Some GUI interactions are convenient and fast, triggering a context menu, clicking an icon. So even if you're doing it repeatedly, you won't think of learning shortcuts sometimes. Some GUI interactions are more costly. You have to go deep into a menu hierarchy to find it, and you search it, and it takes time. Visibility. In order to trigger a shortcut, you need to find out what the keys are. The most common ways are probably just to find them next to menu items or hover on top of icons. People don't seem to always notice them, though, and sometimes the poor visibility prompts users to search online. It's faster. Or even some people print out the cheat sheet to study keyboard shortcuts. Now, after the user finds out the key mapping, they need to memorize it. We found that shortcuts that use the first letter of a command word are easier to memorize, whereas those that use arbitrary letters are not. Our participants keep complaining about the arbitrary mapping of the keyboard shortcuts. Worse than arbitrary keys are modifier keys. The command, control, option, shift, they don't really make sense. They don't really convey any semantic meanings anymore. Physical articulation. The more keys are involved, the less likely the user will learn them. 3 keys may be okay, but 4 keys would be too much. In addition, single-handed shortcuts are more desirable because they free up the other hand to use the trackpad simultaneously. Consistency. Keyboard shortcuts that are system-wide or consistent with other applications are more likely to be used. Perceived risk. This is an important factor. One big reason that users don't use keyboard shortcuts is that they are afraid of making errors, especially when dealing with very important tasks. Feedback. Feedback to keyboard shortcuts are often very implicit. You figure out from the action that you did. But when you make an error, it's sometimes very hard to figure out what has gone wrong. So providing explicit feedback may help improve shortcut usage. Customization. Allowing customization may improve usage because it's customized by the user. They can easily remember what they customized. But there are also issues related to that. Customized shortcuts may also be hard to be communicated or shared with other people. It may also require more modifier keys because you need to avoid what the system has already given you. At the very root, the hindrance of learning keyboard shortcuts is really because it's a different modality than GUI. There's a huge gulf. With GUI, we navigate, point, and then click. With shortcuts, we memorize, recall, then execute. Because of these radically different physical acts, users need to make a conscious and effortful switch. Most likely, they will have a short-term decrease in performance and distracted from their high-level goals. Now, how can we reduce this gulf? Ideally, the gulf can be eliminated if the GUI and the shortcuts are in the same modality. So there can be a smooth transition just by practicing this shortcut because it's in the same modality. But it's impractical to make all GUI, like you can't put all the menus to become in the modality of shortcuts. We know some research such as Expose HK, marking menu is trying to do such kind of thing, but it's sometimes very impractical given the sheer amount of shortcuts. So for our project, we seek to reduce the gulf, if not eliminate it. We aim to provide guidance for keyboard shortcut itself, provide an intermediate mode between GUI and shortcuts for users to learn, rehearse, and transition to directly activating the shortcut. Now, let's briefly talk about how guided FingerArc shortcuts work. We introduced two variations. One is called FingerArc, and the other is FingerChord. Note that in our prototype, because our interest is on interaction techniques, we use infrared camera and tiny visual markers to detect hand posture. We don't use machine learning here. So, FingerArc, it works by pressing and holding a key using an index finger with little ring and middle finger tucked in. Then with the guidance on screen, adjust the thumb angle to select different commands. Expert users can press the key quickly with the same posture directly. At any time, users can cancel these postures just by opening up all the fingers. FingerChord works by pressing and holding a key using middle finger with little and ring fingers tucked in. Sub-commands can be specified by optionally pressing different rows relative to the key that you just pressed. Similarly, expert users can directly trigger the same shortcut with the same chord and posture, and opening the hand for cancellation. Now, we designed FingerArc and FingerChord with a number of considerations in mind, and they connect back to what we found in the interview study. First of all, FingerArc and FingerChord are compatible. They together increase the number of commands that can be associated with each key by 8. Therefore, there are more expressivity. When you have more expressivity, more commands can be matched with the letter key. People have more space to customize and achieve consistency. Another aspect is guidance. We provide dynamic visual guidance to feed forward and feedback, and then enable rehearsal for shortcut key itself. Because now you can directly try out the shortcut, this may decrease the perceived cost of activating shortcuts and increase its visibility. The guidance also provides feedback of the currently selected command and reduce error. We also incorporate some amount of effort using visual guidance, which is press and hold here. So the users will more likely transition to directly activating a shortcut, not remaining in this guidance mode forever. Risk mitigation. The cancellation gesture may reduce users' perception of risk because now they get a chance to cancel. Consistent articulation. You know how regular shortcuts will require reaching fingers to modifier keys at different distances depending on where your finger, the action keys are. FingerArc and FingerChord have consistent finger positioning regardless of where the action keys are. So if you press A, press P, the way you modify this key press is the same. This will simplify the physical articulation. Now, with this design, we'd like to know if they actually improve shortcut learning and usage. So we conducted a controlled experiment with 32 participants to test 4 different shortcut techniques between subjects. The task is very simple. Participants first do a reference task to position their hands. They either type something or they point at a button using the trackpad. Then they respond to a 5-letter word stimulus, triggering a command using menu or the given shortcut technique in the current condition. If they did a round, they will have to repeat the same trial. In the experiment, we have in total 60 commands divided into 12 sets of 5 commands. Each set starts with the same letter. So there are 12 different initials for 12 sets. In each set, 1 command is not assigned with a shortcut. Other 4 commands have shortcuts and are mapped to the same key as their initial. And they are ranked based on frequency of use as primary, secondary, tertiary, and quaternary commands. There are 4 shortcut techniques. Our techniques overload the 4 mapped commands from each set on the corresponding action key using different overloading method. FingerArc detects a thumb angle. FingerChord detects a relative row key being pressed. Guided key is one condition that we include to see what if we just provide guidance to the regular shortcuts. So this is kind of like a regular shortcuts you modify using modifier key, but when you press and hold on the action key, you will trigger a guidance, and you will, when you press something, it will press the modifier key, it will show what you have pressed. So it's kind of mimicking the guidance here. And finally, the regular shortcut baseline. In the menu interface, we divide the 60 commands into 6 menus. Each is visually divided into 2 parts, grouped and ungrouped. The grouped part contains a full set of 5 commands ranked from top to bottom, primary, secondary, tertiary, quaternary, and unmapped command, as we had just have described. And the label of this menu will be the same as the initial of this set. Items in the unmapped part are just randomized across the whole menu interface. The grouped and ungrouped commands here represent the 2 extremes of menu interaction, where users either they have well learned the item's location and locate them almost immediately, or take a very long time to search for the menu items. From all 60 commands, we selected only 4 sets of 20 commands as stimuli. 2 sets are grouped in the menu and 2 sets are ungrouped in the menu. The frequency of these stimuli follows the ZPN's distribution, but with first 8 items excluded. The reason for excluding first few items because we are interested in those shortcuts that are less frequently used, not those that are well known, for example, Control-C or Control-V. So in a block, we will see all primary commands appearing 3 times, secondary and tertiary commands appearing 2 times, and quaternary and unmapped commands appearing only 1 time. We did our experiment starting with 4 blocks of training, And then we ran a test for the 16 shortcuts among the 20 commands, followed by a 5-minute distraction task. And we do another test to see how many are retained after distraction. We then do another 4 blocks of training, followed by a test. And now this time, the participant come in again after 24 hours to do another test. Before we talk about the result, let's just think about what could quantify a successful novice to expert transition. First thing is a modality switch. You will observe users use more shortcuts throughout the time. Second is to measure motor performance, which can be observed from the time change during training. Third is to measure memory performance, which can be observed from expert use during training and memory recall during the test after the distraction. From modality switch, we see from baseline, users start with linear menu, the gray bar, a lot, and then they gradually decrease to switch to using keyboard shortcuts, the green bars, but stabilize at around 50% to 60%. For shortcut techniques with guidance, linear menu usage was very small since the beginning. Look at the gray bar again. And you can see participants gradually transition from shortcut guidance, the blue bars, to direct shortcut activation, the green bars. Then let's look at the time during training. We found there's a learning effect for the first 4 blocks. And then the learning stabilized in the last 4 training blocks. For just the last 4 blocks in grouped commands, we don't really see much difference except for FingerChord was faster than guided key. For ungrouped commands, FingerArc and FingerChord were both faster than guided key and baseline. In terms of expert use during the training, for grouped commands, FingerArc has a significant 15% more expert use than guided key. For ungrouped commands, FingerArc has 15 to 19 more expert use than others. For recall, even though we see some kind of trend, we did not find any significant difference here. One thing to note is that participants on average made 1.2 attempts in a trial to evoke a command, indicating a tendency to minimize errors. We found that 8% of all trials had cancellation, showing that participants indeed take some advantage of the cancellation gesture. Now, as a summary, providing guidance to shortcuts facilitate expert transition. This can be shown from FingerArc, FingerChord, and the guided key, how they start to use guidance from the very beginning and very minimal linear menu usage. Consistent articulation enables better performance than simply providing guidance. This can be seen from the time of the FingerArc and FingerChord, which is for ungrouped commands, is way lower than guided key and baseline. Using finger position rather than pressing a second key to modify the action encourages expert usage. This can be seen from the FingerArc having a lot more expert use than FingerChord, guided key, and baseline. Finally, users indeed take advantage of cancellation. Now, happy to answer any question if we still have time.
We've got time for 1 or 2 questions.
Hey, it's you again.
It's me again, yes. Dan Ashbrook, University of Copenhagen. So you changed, excuse me, you changed a bunch of things from normal shortcuts. So you have different modifier keys, you try to make more semantic shortcuts and so on.
Yep.
I'm wondering what change do you think made the largest difference?
Guidance. I think the video guidance makes the most difference.
Okay.
Yeah.
So can you now back adapt this to better teach normal shortcut keys and help people just remember Command C for copy and
that's actually the guided key, and that's guided key is actually a variation of a technique called expose hotkey. Sorry, I can't really pronounce his family name, but Yeah, so I think that's a great technique. We just want to explore if we can extend that kind of thinking to help us extend our previous work called FingerArc shortcuts.
Right. Okay.
Yeah.
So then the other question I have is, I kept my hand raised for the entire time that you were asking about how many shortcut keys you use because I'm a VI user. So do you think you can use this to teach VI?
I don't know.
Thanks.
Right, thanks.
Hi, I'm Gunnar Park from the KAIST. Thank you for the presentation. I have a question about the FingerArc. So the FingerArc kind of mapped continuous angle to the discrete commands. So was there any physical burdensome or frustration while the participants using the FingerArc?
Yes, that's a really good question. Actually, participants have found it's a little bit difficult to specify an action in between because it's kind of rough, and partly it's my fault because the detection algorithm wasn't that perfect, but if you have perfect algorithm, maybe it's slightly better.
Do you have any solution for those kind of things? I mean, the accuracy to increase the accuracy of those FingerArc?
No, we didn't. We do have error data in our paper, which is very small. I mean, not very small, but we can take that offline. I don't have an answer right off of my head.
Thank you very much.